There is a kind of matter in the universe that cannot be detected or observed. Scientists generally think that 85% of the total matter in the universe is this mysterious matter, dark matter. What is it made of? It has always been the truth that humans want to find out. Astronomers and detectives work very similarly. Before they know the answer, they will have countless assumptions in their minds, and then exclude one possibility after another. In a recent study, a physicist at the Massachusetts Institute of Technology assumed that dark matter was formed by a black hole at the source and explored it. The black hole at the source is also an assumption. At the very beginning of the universe, this kind of black hole is a low-quality black hole formed directly by exploration in an extremely dense area. Their quality may be close to that of a typical small planet, but their size is close to that of a light atom. According to the researchers' calculations, if a black hole at the source flies past within 1 meter of the human body, its effectiveness will push the human body out of 6 meters in 1 second. This means that when a black hole at the source passes through a larger body of matter, it will cause the body of matter to wobble slightly. If most of the dark matter in the universe is really made up of black holes at the source, from a theoretical point of view, they should have at least one chance to pass through our solar system every 10 years. Theoretical existence practice begins. If a black hole at the source passes within hundreds of millions of kilometers from Mars, it will cause the orbit of Mars, which is slightly deviated from the orbit of Mars, to reach about 1 meter in length. Compared with Mars, which is 2.25 billion kilometers away from Earth, this orbit is very small. However, the distance between Mars and Earth can now be measured by humans to reach 10 centimeters. This kind of orbit can be completely detected by high-precision instruments. The research team hopes that in the future, there will be a chance to detect obvious and clear signals in actual observations. Some people may say that we don't really see more stars in dark matter. The black hole at the source is more of a simple assumption. Why does it sound so vague? Is there no other source of dark matter? Of course, there is. In fact, the current mainstream theory believes that dark matter may be made up of weakly interacting particles. Some people also say that dark matter may be made up of relatively light-weighting bamboo particles. But even if humans spent a lot of money to build a detector, we still have no progress in the exploration of dark matter. But human curiosity cannot be stopped. That's why new assumptions keep coming up. I know it sounds a little vague, but these assumptions are not based on imagination. They are based on strict data push and observation results. I think the biggest difference between astronomers and detectives is that detectives deal with blood, clothes, and mouth. Astronomers deal with data. Data never speaks. Data has nothing to do with moral judgment. Data does not extinguish or mutate. Data only waits for people to collect, process, and recover, and then draw conclusions. In the process of scientific exploration, there are too many examples of these seemingly impossible assumptions being verified by observational results. For example, in the 20th century, humans discovered a violent signal source, the gamma rays. The energy it releases in a few minutes is equivalent to the total solar energy of 1 trillion years. Because the energy of the first discovered gamma rays is too strong, scientists are more inclined to say that it originates in the Milky Way. Because if the signal source comes from outside the Milky Way, then its radiation energy is beyond our understanding at the time. At that time, thousands of models of modeling around the gamma rays were made. Both internal and external models are quite perfect. They can all explain the nature and performance of the gamma rays at the time. Until, with the advancement of observation technology, astronomers gradually confirmed the distance range of the gamma rays. This is how the theory of the origin of the Milky Way was gradually abandoned, and the theory and detection of the gamma rays entered a new era. The process of scientific development is actually the process of continuous self-recovery of scientific theory. Such assumptions and arguments are often verified and eliminated over a long period of time. In the end, we find the best explanation for the observational results. If in the next few decades we really see a pendulum that meets the theoretical prediction of the orbit of Mars, then the theory of the origin of black holes in most dark matter will be greatly supported. Research on the second will also enter a new era. I'm Solomon. Thank you for watching, and I'll see you next time.